All right. Well, hello, Honors Algebra 2. If you've made it this far, congratulations. We are officially done with everything that we needed to get to for this school year. So this last week before we have our finals week of sorts is just going to be a chance for me to show you just a few more things about trigonometry that might be useful going into next year. So we're going to focus this week on trigonometric identities. I will still have a quiz for you at the end of this week to check to see how you're doing. Just know that none of this material will be on the final next week since it's not technically part of this class. So that being said, let's jump into things. So our first section is going to be Intro to Trig Identities. There's going to be three things we're going to focus on. We're going to focus on evaluating trigonometric functions, simplifying trigonometric expressions, and explaining the Pythagorean identity using your own words. Before we do that, I've got a brief warm-up for you where I've got three different expressions. I've got cotangent, cosecant, and secant of x, and I would like for you to write those using either sine, cosine, or tangent. So this would be a good time to pause the video and check to see how much you know. All right, let's take a look at those. So for the first one, cotangent of x is the same as 1 divided by the tangent of x. Then you've got cosecant of x. As a reminder, that is the same as 1 over sine of x. And then lastly, secant of x, that is the same as 1 over the cosine of x. Now, these are what are known as reciprocal identities. And we've seen that word reciprocal quite a bit. And it should kind of make sense that it would fit with these types of ratios. So reciprocal identities. Now, there are actually three more of those. If you think about going in the other direction, we could also say that sine of x is the same as 1 over cosecant of x. We could say cosine of x is the same as 1 over secant of x. And that tangent of x is the same as 1 over cotangent of x. So this whole section is going to be about these different identities. We're going to go through basically all of the ones that you need to know for this section as well as later sections. There'll be a few that we'll add in the very last section, but we'll talk about those when we get there. Now, in addition to these reciprocal identities, we also have a couple of other identities related to tangent and cotangent. Both of those functions are unique because they can actually be written in terms of sine and cosine. If you recall, tangent of x was the same on the unit circle as taking y divided by x, which is the same as taking sine of x over the cosine of x. So that would be tangent of x would be the same as sine over cosine. Remember, cotangent is the reciprocal of tangent. So you could think of it as 1 divided by tangent of x. But now that we know tangent of x is sine over cosine, you could write that as 1 over sine of x divided by cosine of x. And then remember, 1 divided by that, you take the reciprocal, which is just cosine of x over sine of x. All right, so those are your tangent and cotangent kind of special ratios that they get, where you can also write both of them in terms of sine and cosine. Now, due to a lack of time, just because I wish we had the time to go through these, but unfortunately we really don't, I'm going to give you some more identities that we will be using. Just know that these are not going to be something we have the time to prove. However, next year, either in College Algebra Trig or in Honors Pre-Calc, you will likely have your teacher take you through these in a little bit more detail than I am. I'm just going to be showing you some basic properties. So this would be a good time to pause the video if you need to write these down. I'm going to go ahead and kind of talk through them real quick though. So hopefully that'll buy you a little bit of time if you are copying these as you're watching. So the cofunction identities. Really, these should be somewhat familiar to us anyways. If you go back to Unit 10, when we were talking about graphs of trigonometric functions, we actually talked about some of these. We just didn't talk about them as being identities. But we did talk about how you could write a sine graph as a cosine graph, or how you could write a cosine graph as a sine graph. We didn't talk about tangent as much with cotangent, but these should feel a little bit familiar if you kind of think about how you had to shift the graph left or right. That's what these identities are saying. The negative angle identities then talk about whether the functions are either an odd function or an even function. The only even function is cosine. So if you notice, cosine of negative theta is the same as cosine of theta. That is because it's an even function. The two odd functions are sine and tangent. And that's because when you take sine of a negative angle, negative theta, that's the same as negative sine of that same angle theta. And same is true for tangent. The last identities, and they also are called formulas, are the sum and difference formulas, which tell you that if you have sine of a plus b, you could rewrite it as sine of a cosine of b plus cosine of a sine of b. And then I'm not going to talk all the way through these. These are just ones to take a moment and pause the video if you need to copy these down. I will just say, if you can remember one set of these, whether it's the sum or difference, to get the other one, you just change all of your signs around. So if you look kind of comparatively at this first equation for sine of a plus b and this equation here for sine of a minus b, you'll notice that the only difference between the two formulas is that when you're subtracting inside the parentheses, that just becomes subtraction when you're using the formula. And vice versa, if you were, for the second one, cosine of a plus b, you were subtracting on the formula. Here with cosine of a minus b, you're now adding for the formula. So as long as you can remember one, you can probably remember the other set of these formulas just because it's a change of sign. Now, there is one more identity that I want to show to you, but I'm not going to give you this one for free. We're going to have to do a little bit of work for it. So let's recall the unit circle has a radius of 1, and that the cosine of theta represents the x values, the sine of theta represents the y values. And so if you need a picture of that, you can look over here on the right of the notes to see kind of what that looks like. So if you think about creating a triangle, and I think we did this when we did our unit circle. So if I were to, from that point on the unit circle, draw a vertical line down to the x-axis to make a right angle, you'll notice that I end up with this triangle here, which I've got outlined for you. Notice that that triangle has a hypotenuse of 1. And if you think about, no matter where you draw that triangle, because it's always going to be a distance of 1 on the unit circle, that means the hypotenuse is always going to be 1. And then if you think about, this would be the x value, this would be the y value. So using the Pythagorean theorem, we can then write that x squared plus y squared has to be equal to 1. Now here's where we go back and think about the fact that x is the same as cosine and y is the same as sine. And so if you think about replacing x and y in that equation, you can get another equation which says that the cosine of theta squared plus the sine of theta squared is equal to, well, 1. We don't really have to change that. Really, the only thing that we will do, just to make this easier to write so that there's not as many parentheses, we can also rewrite this equation as cosine squared theta plus sine squared theta is equal to 1. This is what is known as the Pythagorean identity. And this is a big one because actually just this one identity is then going to have 4 other identities that we can then use. 2 of them are pretty easy. If you think about subtracting cosine squared theta to the right side of that equation, then you get the new identity that sine squared theta is equal to 1 minus cosine squared theta. If you do sine of theta instead, so if you subtract sine squared theta from each side, then you now have cosine squared theta left on the left side is equal to 1 minus sine squared theta. So those are pretty easy. Just divide or subtract either cosine or sine, and you get 2 new identities. The other 2 are a little bit trickier to get, but not too bad. So let's kind of start with our original Pythagorean identity. And then what we're going to do is we're going to go through and divide by cosine squared theta. So we're going to divide here by cosine squared theta, divide here by cosine squared theta, and divide here by cosine squared theta. Now, in doing so, let's think about what this simplifies to be. Cosine squared theta divided by cosine squared theta is 1. Sine divided by cosine, remember, is tangent. And so if they're both squared, then we'd get tangent squared theta. And then 1 over cosine was one of our reciprocal identities. Remember that that is the same as secant of theta. And because it was cosine squared theta, then that would be secant squared theta. So what we've been able to do is now create another Pythagorean identity. We're going to do it one more time. So we're going to start with our Pythagorean identity, the original one. But this time, we're not going to divide everywhere by cosine squared theta. You can probably guess what we're going to do. This time, we're going to go through and divide by sine squared of theta. So going through and dividing by sine squared of theta. let's see how this identity looks just a little bit different. We're going to start cosine divided by sine. That was one of our special ones. That was cotangent squared theta. Sine squared theta divided by sine squared theta is just 1. And then 1 over sine was again one of our reciprocal identities. That is the same as cosecant, so cosecant squared theta. So really, if you think about it, as long as you can remember this identity right here, you've got 4 more identities that you can remember pretty easily just by doing a little bit of manipulating with that equation. Okay, let's take a look at a couple examples and we'll be done with this first section of Unit 12. So in example 1, let's consider we've got sine of theta equal to 4/5, and our angle theta is somewhere between pi over 2 and pi. Let's find the other 5 trigonometric functions of theta. When you're working through these problems, what I would recommend doing is drawing a picture. It's probably the easiest way to make these a lot easier to manage. So it tells us that our angle theta is somewhere between pi over 2, which remember is the same as 90 degrees, and pi, which is 180 degrees. And we don't know what our angle is, but it's somewhere in this quadrant here. And so we're just looking at, okay, we've got sine of our angle theta is equal to 4 over 5. But remember, when you're looking at sine, let me just write this over here. Remember, sine is the same as taking your opposite side divided by your hypotenuse. So if you think about opposite over hypotenuse, that would mean that in terms of our angle here, theta, that the opposite side, 4, would be this side, and then the hypotenuse, which is this side, would have to be 5, which really means we're just missing one of these sides. And if you think about how we could solve for that, we just need to use Pythagorean theorem. So we'll say x squared plus 4 squared is equal to 5 squared. Then we can simplify that. X squared plus 16 equals 25. So then x squared would have to be equal to 9. And x would have to be either positive or negative 3. Now you might be sitting there thinking, well, it's a triangle. Can it really have a negative side length? And while it might not be able to have a negative side length, notice that you're in the second quadrant. That means that you could have a negative direction for that distance, in which case it actually is going to be negative 3, not positive 3, which is going to be our value for x. Now, what it wants us to do then is to find the 5 other functions of theta. We already know that sine of theta is equal to 4 over 5. Let's also find cosine of theta now, and then find tangent of theta. Now you might be wondering, well, what about the other 3 ratios? And we'll get to those. Let's find these first, and I'll show you kind of a quicker way of finding those. So cosine of theta, you're looking at your adjacent side over hypotenuse. Well, adjacent is negative 3, hypotenuse is 5, so there would be cosine. Tangent, remember, is opposite over adjacent, so that would be opposite of 4 over adjacent of negative 3. So now let's go back and let's do this. Let's find all the reciprocal identities, so cosecant, secant, and cotangent. Now here's the nice part, is that if you did this in the same way I did, now you're going to have an advantage, because remember, reciprocal just means take your fraction and flip it. So cosecant, being the reciprocal of sine, would just be 5 over 4. Secant is the reciprocal of cosine, so that would be 5 over negative 3. And cotangent is the reciprocal of tangent, so that would be negative 3 over 4. All right, in example 2, we're going to get our first taste of verifying trigonometric identities. This is actually going to be very similar to what you'll see all of next section of the notes in just a little bit. So what we're going to try to do is just simplify this as much as possible. So we're going to rewrite these in any way we can, and then try to see how simple, if we can write it. Our goal would be to try to write it as just a single trigonometric ratio if we possibly can. But we'll have to see if we can actually do that. So taking a look at example A here, example 2A. We've got tangent of pi over 2 minus theta multiplied by sine of theta. So tangent of pi over 2 minus theta, if we go up to our cofunction identities, tangent of pi over 2 minus theta is the same as cotangent of theta. So let's do this. Let's just start by replacing that with cotangent of theta. And then we're still multiplying by sine of theta. Okay, that's a little bit better looking. Let's see if we can simplify a little bit more. Let's do this. Let's rewrite cotangent of theta in some other way. Now, I guess one thing we could do is we could rewrite cotangent of theta as 1 over tangent of theta, but I don't know that that's going to help us a whole lot. Let's instead rewrite cotangent of theta as cosine over sine. And let's see how that will maybe help us simplify. So cotangent of theta, we're now going to rewrite as cosine of theta over the sine of theta multiplied by the sine of theta. And now you can probably see something we can do to simplify, which is that we can divide out sine of theta divided by itself. And so we're actually able to simplify this all the way down to a single trigonometric equation or expression, which is cosine of theta. Okay, let's take a shot at B here. So we've got secant of theta multiplied by tangent squared theta plus secant of theta. Now, something kind of interesting we can do, if you look at both of the parts of your expression, both of the terms, they both have something in common. They both have a secant of theta in common. So let's do this. Let's factor it out like it's a number or a variable. So let's think about what would be left. We'd obviously have tangent squared theta left for the first part. And then when you're taking secant of theta and dividing it by itself, remember that that's going to give you a 1. So now inside the parentheses, we've got tangent squared theta plus 1. Let's look to see if we can do anything with that. So up here, I don't really see anything. Tangent plus 1. Let's look at our Pythagoreans. And hey, what do you know? It's written in a different order, but 1 plus tangent squared theta, still the same as tangent squared theta plus 1. And it tells us that that is equal to secant squared theta. So let's do this. Let's replace what's in the parentheses with secant squared theta. So now we've got secant of theta multiplied by secant squared theta. And it's best to probably think about these as variables. If you're taking x multiplied by x squared, that's x to the third. So if you're taking secant of theta multiplied by secant squared theta, that's the same as secant to the third of theta. All right, that's all I've got for you in this first section. We will be doing a lot of stuff similar to examples A and B in the next section of notes, where we're verifying trig identities, trying to show that one expression is equal to another. I will talk to you then.